All right, let's begin. It's recording. Exercise 8E. So today's lesson is going to be easier than the other lessons that we had. Less theoretical, probably just more a tool for you to use when you have problems that may involve what we call two-step experiments. One of the techniques that we use is a two-way table, which is also known as a cardinal map, but usually we call it a two-way table. So two-way tables, we use that when you have a two-step experiment. What is a two-step experiment? It means that your trials, you are not just doing the one roll or one flip or one spin. You are doing two things, one after the other. So in this case, it would be, say, rolling the dice twice. It could be flipping a coin twice. It could be rolling a dice and then flipping a coin. Now, you don't have to use a two-way table. It's just one of the tools that you could use. I mean, I could have done, for example, if I were to do roll a dice twice, I could have done it as, on the first go, when you roll a dice, you can get options of 1, 2, 3, 4, 5, 6. And that's using a tree diagram, so that's my first go. On my second go, that would mean that I could get 1, 2, 3, 4, 5, and 6. So my possible options or outcomes here is I could have got 1, 1. So 1 on the first go, 1 on the second go. I could have got 1 on the first go, 2 on the second go, 1 then 3, 1 then 4, 1 then 5, 1 then 6. The problem with doing it in a tree diagram is drawing 6 options for every further 6 options here is a bit harder diagrammically. It just looks more messy. So tree diagrams are nice when it's 2 or 3 branches. When you go beyond 3 branches, then it's kind of like, well, is there a better way? So a two-way table and a tree diagram still works for this scenario. It's just that a two-way table is neater. Okay, still to be able to see all the possible options. So let's do a quick example here. Example 1, you've got a fair 6-sided die and you're going to roll it twice. So the options are, if you roll it once, you could have got 1, 2, 3, 4, 5, 6. And the other one, if it's a dice again, well, then you got 1, 2, 3, 4, 5, 6. Had it been, say, roll a dice, then flip a coin, then you would have changed this section and call it heads and tails. And then you get your options in there. Okay, so here we get 1, 1, 1, 2. Oh, sorry, it should be. Usually we say the first roll is on the row and the column is the second one. So there should have been 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. This is then 1, 2, 2, 2. Maybe I should just do it this. 1, 3, 1, 4, 1, 5, 1, 6. 2, 3, 2, 4, 2, 5, 2, 6. 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And your last row, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Now this scenario could also have changed depending on the question. This is just a simple question of just saying you roll a dice twice and then what are your possible options. We can already see here it's a 6 by 6. What's my total possible options so far? What's my total? 36, because 6 by 6 gives me 36 possible outcomes. Now let's answer the question. It says, find the probability of obtaining outcome 6, 4. So it says 6 on the first go and then 4 on the second. So here's 6, then 4. So technically it should be 1 outcome. So it depends on the wording of the question. If the question was just saying getting a 6 and a 4, well, there are 2 ways of getting a 6 and a 4. You could have got a 4 and then a 6. As well. If they say 6 on the first go and then 4 on the second, that's very specific in terms of order, then that would be 1 out of 36. If they just say getting a 6 and a 4, then there would have been 2 out of 36. So just be careful with the scenario. In this case, this is a bit vague. Find the probability of obtaining the outcome 6, 4. So because they wrote it in brackets and they wrote it in this particular order, this technically means 6 on the first go, 4 on the second. okay, because there's an order to it. Had they just said getting a 6 and 4, then you can get a 6 and a 4 in many ways, okay? So this scenario here, I would say because they wrote it in this coordinate form, there is only one that actually fits that scenario. So hence this would be 1 probability of getting a 6 and then a 4 in that particular order is equal to 1 out of 36. Okay. All right, let's do the next one. So notice this one now says find the probability of 3, 2 and then or 2, 3. That's an example where the order didn't matter. Okay, so in this case, you either get a 3 first, then a 2, or you get a 2, then a 3. Okay, so what would the probability of getting a 3 first, then a 2, or, which means union, 2, then a 3? What's the probability here? Let's go, yes, Mira. 1 out of 18. How did you get 1 out of 18? Beautiful. So when we're unioning, we're looking at, well, what's the chances of getting 3, 2? Well, 3 on the first go, 2 on the second. Here we go. That's 1. Or you can get 2, then 3. Clearly, there's 2 possible options that you can get. So you get 1 or the other. So there's 2 options that you have out of the 36. So it makes sense that you'd say 2 out of 36, but you don't leave your answer as 2 out of 36. You must simplify to 1 of 18. If you don't simplify to simplest form, you will lose marks. It has to be simplest form. Yes?
So if it said and instead of O, would it just be 1?
If it said and, so probability of getting 3 or 2 and how do you get and? Yeah, you can do. Well, can you do and? I feel like and doesn't make sense because you roll it twice. What's the chances of getting? It would be impossible because you only get 2 rolls. If you get a 3 and a 2, it's not possible to get and getting a 4 and a 5 at the same time, because and normally implies that your outcome is finalized, if that makes sense. So it's like saying, because you're only rolling it twice, you're asking me, what's the chances of getting a 3, 2, and 2, 3? But you're only rolling it twice. So to get that in 1 roll or 2 rolls, it's impossible. So, but the or makes sense. The or is saying you rolled it this way, or you could have rolled it this way. And usually implies that it happens at the same time, simultaneously. So then when you roll it twice, you couldn't have got and a 2, 3 as well. That's usually the difference. That's why and is like, when do they both intersect? So they happen at the same time. And or is union, so you just group them together. But I understand what you mean. The word and or can get really confusing. All right, let's go with, okay, so 1 and 18. Next one, probability that a sum at least 9. So that means if you add the 2 numbers together, it is at least 9. Now, you can draw a 2-way table to figure this out, or you can do this intuitively as well. Let's do it the intuition way first. When you say sum at least 9, what 2 possible numbers can you think of already? What 2 numbers can I roll that will give me at least 9? Give me a pair. 4 and 5. So you can roll a 4 and then roll a 5. What else can I also roll? Let's go with Sean. You can do 3 and 6. What else can I possibly roll? Let's go with Yuna.
Right, 9 or at least?
At least 9. Yeah, it says at least.
Cross 4 and 6.
4 and 6. Now we can sit here and write this out, and we can write it in a systematic way to all the 4s, because 4 plus 5, 4 plus 6, 3 plus 6, that's about it. And then 5 onwards. So 5 plus 5, 5 plus 6. So you can do an order, but what's a better way to do it? You can use, again, a two-way table to illustrate this idea. And that way, you can see it better. There's more systematic to it. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. And hopefully you realize that the smallest number, which is to get a 9, it was 3 and a 6. So 3, 6 is 9 here. 4 and 5 would have gave you a 9 here. And then 4 and 5 would have gave you a 9 here. And then 3 and 6 would have gave you a 9 here. So what you see is this section onwards will give you 9 and more. So if you list it out, you can now see 6 plus 4 is 10, 6 plus 5 is 11, 6 plus 6 is 12, this is 10 here, and then you'll see a pattern. You see that diagonal pattern? So just finding at least 9, you do 3 plus 6 gives you, 3 plus 6 gives you 9, 4 plus 5 gives you 9, 5 plus 4 gives you 9, 6 plus 3 gives you 9. It gives you this diagonal. So if you did it this way, it becomes very visual. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of how many again? 36. So this one should have been at least a bit easier once you have a tool. So two-way table is what I recommend, but you could have done it intuitively as well. 10 out of 36. That gives you 5 out of 18. Beautiful. What about sum less than 4? Sums less than 4. Again, you can use a two-way table, or you can do it intuitively. I'm going to pause the video. I'm going to pause the video. I want you to answer C. Let's go. Find the probability of a sum of 3, given that the sum is at most 4. Here we go. So let's break it apart slowly. It says find the probability of a sum of 3. So it has to add up to 3. So what's the chance of adding to 3? Given that the sum is at most 4, meaning 4 or less, right? So this is what we know that's already occurred. We know that they've already added 4 or less. The conditional probability essentially is saying, when do these two occur at the same time? So sum of 3, so out of the group that is less than or equal to 4, how many of those are actually equal to 3? So that's what you're saying here. Which one is less than or equal to 4 but is actually equal to 3? Where do they both occur? So what's the chance of that happening? The total probability is not out of 36 anymore, it's out of the ones that add up to 4, maximum. So that's where the total is probability sum less than or equal to 4. But sum equals to 3 intersecting sum less than or equal to 4, really that's just meaning, where do they both occur at the same time? Sum equals 3. Once you've got this notation correct, now it's just looking at a two-way table to answer the question. What's the chances of it summing to 3? For those who are questioning this line, this is a key line. These two are the same lines. Why? Because one is saying 4 or less. Right? 4 or less. Whilst this one is saying 3. So when I asked you where do they both occur at the same time, it's not when it equals 4, it's not when it equals 2 or 1. This is the only time where sum equals 3 and sum less than or equal to 4 are the same. So that's why its probability of the sum equals to 3. Okay, so that line is key to understand. Then sum less than or equal to 4, well, it's very similar to the last example I gave to you. So let's put it together. So using the two-way table, what's the sum equal to 3? Well, sum equals 3, there's only 2 out of 36. So 2 out of 36 over sum at most 4. So 1, 2, 3, 4, 5, 6. 6 out of 36. Divide them, 36 cancels out. 2 6 is 1/3. Can I get a show of hands? Who've got 1/3 as your answer? Oh yeah, not bad. Not bad. That was a tricky one. That was a tricky one. All right, well done. You can have a go with the next section. I'm going to write the solutions. I'm going to give you about 7 to 10 minutes. Flip over. Have a go with the next one. All right, let's check your answers. So first one. Thank you. When you're doing a two-way table, it does help to see what's happening. In this scenario, I actually prefer doing a tree diagram, so I just went on with the tree diagram. But you could have filled out R1, then R2, and you can write out all the possible options and then count them as well. That works. I prefer doing the tree diagram just because I noticed that there are 2 reds, and I just wanted to change it to probability straight away. So I just went with, first go, you could have got a red, blue, or white. But there are 2 reds, so out of 4 colors or 4 possible ones that I could have chosen, 2 out of 4 is getting the reds, 1 out of 4 is getting a blue, 1 out of 4 getting a white. Because it says without replacement means once you take it out, you don't put it back. So that means after you, out of the 4 options you had, the next go that you pick, there should only be 3 options left. So that means red, you still have 1/3. Blue you never took because the first go was a red, so it's 1/3, 1/3. Each one will slightly be different. If you took a blue, well then there won't be another blue for the next one. You still have a red, or 2 reds, 1 white. If you took a white, thank you. If you took a white, then there's no more whites on the second go. You got 2 reds and then 1 blue. So if you lay it out this way, this tells you more information, especially if you're dealing with probability. So you have to kind of decide what kind of questions are they asking. Is it easier to visualize through a table, two-way table, or is it better with a tree diagram? So I went with tree diagram. Now answering the first question, it says obtaining a red car first, then a white car. So most people should have been able to see getting a red car first, then a white. So there's only one option there. So it's 2 quarters, so by the multiplicative rule, you've got 50% chance of getting a red, and then you've got a third 30% chance of the 50% to get red then white. So it's 50% times 33%, or 2 quarters times a third. That gave me 2 out of 12, 1 6. Hands up if you got 1 out of 6 for the first one. Good? Okay, so that's the first one. So most people should be able to figure that out with the tree diagram, becomes more obvious. Second one, selecting 2 red cars. Same idea. There's only one way of getting 2 red cars because the other ones were different colors. So R1 then R2. So you can see here, getting 2 red cars, you got 2 quarters of a chance of getting a red car in the first go, because you could get R1 first or R2, so that's why it's 2 out of 4. Then there's only 1 left, so you get 1 out of 3. So 2 quarters times a third, again you get 1/6 chance of getting 2 red cars. And again, if you did a two-way table, you would have seen it. You would have done R1 then R2 plus R2 then R1, so you would have got the same answer. Okay. Next one. Selecting 1 red car and 1 blue car. Why did they say 1 red and then 1 blue? Is because they're trying to tell you the order doesn't matter. They're saying that you can get the red first, then blue, or you could get blue first, then red. So that was a hint that these were the 2 ones that they wanted, a blue-red or a red-blue. There was only 2 branches that would have gave you that. So it's 2 quarters times a third or a quarter times 2/3. And if you work that out, 2 quarters times a third or a quarter times 2/3. Together you get 2 out of 12 plus 2 out of 12, which is 4/12. Simplifies to a third. Can I get a show of hands who got the third one correct? Good, so that's learning to read the question. 1 red, 1 blue. Order doesn't matter. Last one was tricky, but same idea as the example I did in example 1. Selecting 2 red cars. So what's the chance of selecting 2 red cars given that at least one of them is red car? So I wrote it as in terms of my notation. What's the chance of getting red and red? Given you already knew you got 1 red. So at least 1. conditional probability means? Well, it's not out of 16 cars anymore, or 16 possible options. It's now out of the at least red. Now you look at the tree diagram, at least red, anywhere that has an R is included. That's included, that's included, that's included because it starts with R. This is included, but not that. This is included, but not that. So there's only 2 branches that you wouldn't include. So that means it's not out of the 16 possible options. Technically, it's out of 14 possible options. Okay? So, because of that, all I did was I said, okay, let's interpret this. What's the chances for these 2 to occur at the same time? Getting 2 reds and at least 1 red. There's only one way to get 2 reds and at least 1 red to match, is if they're both reds. Okay, so that one there, that interpretation, that line, I find that sometimes my year 12s find that difficult. This year's year 12s actually picked up this idea much better. Year 11's usually the first time I'm teaching that. They get it confused. So being able to interpret that to become this. Next one, at least R. Instead of adding all the 14 out of 16 options, I decided to do the reverse. I said the total probability is 1. Then I minus the 2 branches I didn't want. Getting a white and a blue, or getting a blue and then a white. These are the ones I didn't want. Has nothing to do with reds, so if I did 1 minus that, I should get at least red. It's much easier than doing red, 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 white, red, blue, and then blue, red, and all that. That takes too long to add. So I did the reverse to get there. If you do that all correctly, you should get this. R&R is 2/4 for the first one, then 1/3, which is the one you did beforehand. 1 minus, getting a white then blue, and blue then white. It ends up being 2 out of 12 divided by 1 minus 2 out of 12. Well, then that gives you now 10 out of 12, and that's 2 out of 12, so 2/10, which is 1/5. This was a tricky one. Hands up, you got this one correct. Oh, wow, beautiful. That's really good. That's as tough as it can get for exercise 8E on 2-way tables, conditional probability. Okay, I'm going to stop the video there.